可以开始。然后第一题的结果，首先就是有过我们先设 I1 是会流过那个第一个电阻 R1，然后 I2 是可以流过 R2 的，然后两个会一样。然后我们可以用关系式得到E 等于这个 V1 等于 V out。好，现在选例外比较简单一点，比较简单一点。是 R1，然后E2因为它是并联，所以就然后整理一下这一边的关系，可以得到就可以得到你要的，然后再你要的就可以用impedance 来解出我们要的值，然后把它稍微整理一下，变成。要经过一些复杂的整理，会最后就可以把它整理成这样。然后根据提示，我们把它这个提示的样子，然后这边就总除以 R1，就可以变成提示上面的样子。
So firstly, I need to talk more about the transfer function, how the formula is being derived in English. The first thing is this, based on the question given to us, it represents the inverting ops amplifier. So how do we get this formula, which is the impedance, the first impedance and the second impedance? The first impedance is being calculated by combining the resistor 1 with the capacitor. What do I mean by that is by series combination of the resistor and the capacitors give us the impedance 1. Then the second impedance gives us by combining the parallel combination of the resistors and the capacitors give us the impedance 2. So, and the formula for getting the transfer function is the output VO over the input. And we should not forget that for the inverting ops amplifier, it is minus, it is negative. That is why we got negative here, because for inverting ops amplifier, there must be negative, because the input terminal is negative. Then based on combining with the gain, it will now give us the output, which is called the VO. So now I want to talk about how to plot the transfer function by applying the mid-band gain the lower frequency and the upper frequency. First of all, mid or band gain. So in this principle, we need to neglect the capacitor 1 and capacitor 2 are being negligible. So if we neglect the capacitor 1 and capacitor 2, the mid band gain, which is AM, equals to what? Equals to R2 over R1. Of course, we need to put the negative because we are dealing with inverting ops amplifier. Now, the second thing is lower frequency. Lower frequency. Lower frequency. Yeah. Based on the question given to us, the lower frequency is being get from it's being get from C1 capacitor 1 based on the diagram because it goes like this. We have a resistor 1, then we have a resistor 1. Yeah, we have a resistor, we have a capacitor here, a capacitor, this is capacitor 1, this is resistor 1, then we have, it is being connected to inverting ops amplifier. Then, of course, for inverting amplifier, no current will flow in, into the input terminal. Then it goes up this way, where we have the resistor 2. This is the output voltage. We also have the capacitor 2. We have the capacitor. So this side deals with lower frequency, while this side deals with upper frequency. We call it H upper. We call it this H lower. So I don't want to waste most of our time. Then I just need to put in the formula for the lower frequency, which is WH equals to what? 1 over R1 C1. While that of upper frequency, which is upper or higher frequency, is what? 1 over R2 then C2. So now, what do we need to do next is to plot the graph or diagram for the border. So how do we plot the plot? How do we make the plot? It's by, of course, let's say this is x-axis and this is y-axis. Then we need to apply the W. Then this is log. Of course, we have 20 decibel, and the first thing we should take a look is AM, which is the mid-band gain. Mid-band gain is between the upper and the lower frequency. So let's first consider the lower frequency. For the lower frequency, we need to know that the gain increased by 20 decibel. That means we need to plus 20 decibel, and for the higher frequency, we need to make minus 20 decibel. And for the mid-band gain, it is flat. Like it does not increase, it does not decrease. That is where we have let me just put 20 decibel because it does not increase and it does not decrease. So how do we make the plot? Is by constructing, by starting with, we need to start with, let's say this is W let's say this is W, this is WA. Then plus 20 decibel goes up this way because the lower frequency is being increased by like its gains of 20 decibel. So it goes up this way. Then the mid band gain is constant. It does not increase and it does not increase. So the plot goes flat. Then the the upper frequency rather goes because it's decreased by 20 decibel. It goes down this way. So for this mid band gain, like it is 20 log out to how one log 10 rather log 10 out to add 1, and this is decibel, this is log. So this is how to plot our border plot for the magnitude response.